Hello, dear students. Let's start the new chapter Saturated Hydrocarbon Alkanes, chapter number 9b of class 10th in subject chemistry. Now, in this class, we will discuss about the introduction of the alkanes and the laboratory preparation of the alkanes by different methods. So let's open your chemistry book and come on the page number 239. Now alkanes. Alkane is the simplest organic compounds that is only made up of carbon and hydrogen, nothing to else. Only carbon and hydrogen. So it is a type of hydrocarbon, saturated hydrocarbons. And the general formula of the alkane is CnH2n plus 2. Alkane is also called the saturated hydrocarbon because the single covalent bond present between the carbon and also carbon and hydrogen. So the alkanes are chemically inert due to a strong covalent bond between carbon and hydrogen. Hence they are called paraffins. Paraffins, it is a Latin paraffin words derived from the Latin word param, means affix or little affinity. Param means affix, that means little affinity. So alkane have the little affinity towards the reaction. Now the homologous series of the alkane, if the number of carbon is 1, then the IUPAC name of the alkane is methane. It is also called the marsh gas. The molecular formula of the methane is CH4. Condensed formula of the methane is CH4. The structure formula is CHHH and H, 4 hydrogen and 1 carbon. Second one, if carbon number is 2, then ethane, and the molecular formula of ethane is C2H6. Condensed formula CH3. Structure formula C, 3 hydrogens and C, 3 hydrogens. Propane, if the carbon number is 3, then the IUPAC name is propane. Formula is C3H8 and the condensed formula CH3, and the structure formula 3 carbons and total 8 hydrogens combined with the carbons by a single covalent bond, and all carbons are combined with another carbon with a single covalent bond. Now next, if the number of the carbon is 4, then butane, formula C4H10, condensed formula CH3, 4 carbons combined with each other by a single covalent bond. Now if the number of carbon is 4, then the another compound, if the number of carbon is 4, then the another compound branch chain of the alkanes, that is 2-methyl propane. This one is the 2-methyl, this one is the 3 carbon propane, or it is also called the isobutane. The condensed the molecular formula is C4H10 and condensed formula is CH3. So this one is the condensed formula, this one is the structural formula of the 2-methyl propane. So these all are the homologous series, member of the homologous series of alkane. Now the occurrence of the alkanes. The two main sources of the alkanes, number 1 sources natural gases and number 2 petroleum. Natural gas that contains 80% methane and 10% ethane, and the remaining 10% being a mixture of higher member of the alkanes. It means 80% alkane, 10% ethane, and the remaining 10%, the higher member of the alkanes are present in the natural gas. In the petroleum is also a cheap source of the alkanes. Petroleum contain up to 40 carbon compound, 40 number of the carbons of the alkanes. Now methane is the main constituent of the coal gas. CH4 is the main constituent of the coal gas, and it is found in marshy places where it is formed by bacterial decomposition of vegetable, animal matter, and hence it is called the marsh gas. So methane is also called the marsh gas because it is present, it is found in the marshy place due to the decomposition by the bacteria of the vegetable and animal matter. Methane is also found in coal mines where it forms explosive mixture with air. So it start to burns with air, and therefore it is called the fire damp. So methane is also called the fire damp. Methane is also called the marsh gas. Now the presence of this explosive mixture in coal mines, the main cause of violent explosion is due to methane. Now isomers of the alkanes: methane, ethane, propanes do not show the isomerism. Butane, so there are two types of the isomeric forms, N-butane and 2-methyl-propane. Pentane exists in three isomeric forms, N-pentane, state chains. Now in the branch chains there are two. Number 1, 2-methyl-butane and 2,2-dimethyl-propane. So in the case of pentane there are three isomeric forms. One is the pentane, and second one is the 2-methyl-butane, and third one is the 2,2-dimethyl-propane. Now hexane exists in 5 isomeric forms, N-hexane, 2-methyl-pentane, 3-methyl-pentane, and 2,2-dimethyl-butane, and 2,3-dimethyl-butane. So 2,2-dimethyl-butane and 2,3-dimethyl-butane. So there are 5 isomeric form of the hexane. Now the preparation of methane in the laboratory methods for the preparation of methane: from sodium ethanoate, sodium acetate, it's called the sodium acetate, CH3 COONA. It is the sodium acetate, formula of the sodium acetate. Now the reactants required for the laboratory preparation of methane are sodium ethanoate and soda lime. Soda lime, it is a mixture of NaOH and CaO. So soda lime, it is a mixture of NaOH and CaO. Now the procedure: first, heated the mixture of sodium ethanoate and soda lime in a hard glass test tube. After heating the mixture of sodium ethanoate with the sodium and soda limes, then the methane gas is evolved. Methane gas produced and evolved. Let's see the reactions. Sodium ethanoate react with NaOH, calcium oxide, then heated the mixture of sodium acetate and soda lime, then it produces the methane gas that is evolved during this reaction in the glass test tube. And this reaction is also called the decarboxylation reaction, because in this reaction the carboxyl group, carbon dioxide group, COO group, removed from the sodium ethanoates. So decarboxylation reaction. Let's see the diagram. First, taken the sodium acetate and soda lime in a test tube and start to heat by the help of the burner. Then the methane gas is produced in the tube, and that methane gas is passes through the delivery tube into inverted gas jar, and methane gas is collected into the inverted gas jar by the downward displacement of the water, because methane is lighter than the water. Now the collection. Methane gas is collected by the downward displacement of water, since it is only slightly soluble in water and hence it is lighter than the air. So methane is slightly soluble in the water and also methane is lighter than the air. So methane easily displaced downward to the water and collected in the upper region of the gas jar. Now the reason for using soda limes in this reaction, we can observe that only the NaOH is react with the sodium acetate. But why we can using the mixture of NaOH and CO, that is soda lime? In this reaction only NaOH react, but as a reactant soda lime, that is a mixture of sodium hydroxide and calcium oxide is used. This is due to the reason that soda lime is not deliquescent and does not attack the glass, does not attack the glassware. Now other method, the production of the methane by reduction of methyl iodide, that means iodomethane. The reduction of iodomethane is carried out by nascent hydrogen that is produced by the zinc copper couples in alcohol. So whenever zinc copper couples added in the iodomethane, then zinc copper couple with alcohol is produces the nascent hydrogen, and that nascent hydrogen replaces the iodine and form the Hi, and one hydrogen combined with the CH3 to form the CH4, methane gas. So from the iodomethane we can also produces the methane gas by using the zinc copper couple in alcohol. Now the preparation of ethane, the second member of the alkane is the ethane. So laboratory methods is similar to the preparation of the methanes. Now in the laboratory methods from sodium propionate. Now here only you can use the sodium propionate, and in the case of methane we can use the sodium acetate, but here you can use the sodium propionate. Now reactants required sodium propionate and soda lime. Now the procedure is similar. Procedure: a mixture of sodium propionate and soda lime is taken in a hard glass test tube and strongly heating the test tube. After heating, the ethane gas is evolved, and that ethane gas can be collected in a particular container by downward displacement of the water. So ethane gas is collected by downward displacement of the water. Now other methods for the preparation of the ethane is by reduction of ethyl iodides by using the zinc copper couple in alcohol. So zinc copper couples produces or provided the hydrogen ions, and that hydrogen ions combined with the ethyl iodide, and that iodine replaced from the ethyl iodide and from the ethane, and hydrogen iodide release as a byproduct. We can also use the ethyl bromide. Ethyl bromide also produce the ethane gas and as a HBr as a hydrogen bromide as a byproduct. Now the another method by Wurtz reaction. Now Wurtz reaction. So first, what is the Wurtz reaction? When methyl bromide or methyl iodide, anyone, react with the sodium in the presence of dry ether, then they produce the ethane, and that reaction is called the Wurtz reaction. So anyone, methyl iodide or methyl bromide. So here we can take in the methyl iodide. That two molecule of the methyl iodide react with the two atoms of the sodium in the presence of dry ether, they produce the ethane gas and sodium iodide as a byproduct. But by the Wurtz reaction, we can't produce the methane. So minimum two number of the carbon have to be produced by using the Wurtz reaction. So in the Wurtz reaction, methyl iodide or methyl halide react with the sodium in the presence of dry ether to produce the ethane gas. Okay, this is all about the ethane, all about the alkanes and their laboratory preparation. Okay, thank you, have a nice day.